This was a video solution to one of the problems for confidence intervals in the online homework. And I'm going to show you how we did it in class with the different steps that we had on the worksheet. And then I'll also show you real quick how you can use StatCrunch to get some of these answers in a faster way. It has a calculator that'll do some of these things for you exactly. So in this question, we had a survey question that asked, what does it ask? Should it be government's responsibility to impose laws to industry to do less damage to the environment? And 1,408 out of 1,492 subjects said yes. So that's a very high percentage if you think about it. So this is a question that most people said yes to. The reason that that's relevant is that there are some assumptions on our methodology, our theory, that makes everything work correctly. And the most important thing is that we are gathering the data randomly and that we have enough data. And so the exact meaning of those two things are always in these sentences asking if we have the assumption satisfied. So this question here is just asking if we're collecting data randomly, and that's always essential for what we're doing. All of our theory is based on the idea of randomness. So that is actually one of the harder things to achieve when you're really designing surveys, is to make sure you have a random set of a random sample. But for our class, we're just worried about the mathematics, and so we will just assume that we do have random data. The number of successes and the number of failures, the general rule of thumb is that you need, well, I shouldn't use that symbol. You should have at least you should expect at least 15 successes. So that means in this case of this question, yes answers, and at least 15 no's. And so a very conventional wisdom that you may have heard of is that your sample size needs to be at least 30 before you can infer anything. And that's true, that is the very minimum number. But in a question like this that's so heavily skewed towards the yeses, we need a much larger sample size, because we need to have the expectation of kind of having a minimum number of yeses and a minimum number of no's to our question. So 30 is the absolute minimum, but when the question is really skewed like this, we need a lot more data. But anyway, in this case, we definitely have that. We have almost 90 no's and 1,400 yeses, and so we have a big enough sample size that we can continue. And that's what that says. All right, so the question really here is asking us about building a 95% confidence interval. So let me do that real quick based on the way we did it. We first of all calculated our p-hat value, and in this case they didn't tell us that, but it was 1,408 out of 1,493. No, it was 92. So 1,408 out of 1,492. And this is about point, and it does say probably I need 3 decimal places for my final answer, so I'm going to give myself more than that at each of the steps along the way, just so I'm confident that I get all decimal places right. So this is 0.9437 to 4 decimal places. So in my work, I'm trying to go 1 decimal place beyond what they're asking for in the end. We know our second step is to try to find the standard error. And that's this formula that you can't even believe that it would be this messy, but it's p-hat times 1 minus p-hat divided by the sample size, which is 1,492. That's the total number of people that you asked the question to. And one way to keep straight that 1,408 is not relevant yet here. Well, anyway, so it's the sample size. So don't get confused about which number that is. That's the number of people you asked the question to. And then for standard error, we have to take the square root of that whole final answer. And so that's a calculator thing. Make sure that you know how to do that on the calculator that you have for this class, and so that you get the parentheses bound right and the square root in the right place. But hang on, when I get it, let me do it real quick on my calculator. All right, so when I do it, I get, and again, I'll try to round this off to more decimal places than I know I need, just to make sure, but this is a very small number, 0.00597. So really very close to 0.006. Then the third step is to do the margin of error. And that's just going to be a multiplier by the standard error. Remember, the standard error is the standard deviation in our distribution, and then we're trying to see how many standard deviations up and down again. So, so the margin of error is going to be plus or minus. Well, that's what I always say. I don't know that's not what they want us to write. But the margin of error will be 1.96 times the standard error. And the reason that it's 1.96 is because that's the magic number of standard deviations that we need to get 95% of our data. So the confidence level that's given in the problem, 95%, is telling me to use that value. We have a different value for 99% confidence intervals, a different value for 90% confidence intervals. But as we use them, we should just make little notes in the margin. We don't want to have to keep going back to that table every time we want to use one of them. But that's where the numbers come from. The numbers come from our table, but we don't want to have to keep going back over and over again. So 1.96 times the standard error. Hang on one second. All right, I get 0.0117. 0.0117. And again, I know that's more decimal places than they asked for, but I'm doing that on purpose, so I have plenty in the end. I get 0.011696. 0.11, yeah, so 0.0117. So the confidence interval is just going to be my p hat minus margin of error to p hat plus margin of error. And they seem pretty consistent with the convention that they want the smaller number first. Usually when we describe an interval in math, we describe the smaller number to the bigger number because we're visualizing like the way a number line works. On a number line, left to right goes smaller to bigger. And so that convention is consistent with what you do in the rest of math. But in the English language, the order doesn't matter when you say between things. So that can be a little confusing, but we'll always just put the smaller number first. So if I do that, my p hat minus margin of error is 0.9437. That's p hat minus 0.0017. And so going from that number to this number, 0.9437. I've got a cat who has joined me. Hello, Teddy. So those are the two ends of the confidence interval. Let me do those calculations real quick. And I have from 0.932, and here I do have my 3 decimal places, to 0.955. And so those are the numbers that will go into my my boxes up there. Okay, now at the beginning I said I promised that I would also show you how to do this in StatCrunch. And if you're using a TI 84 calculator and are interested, I can show you how to do that as well. I can't demonstrate that on my tablet, but if you have a calculator like that and want me to give you a quick demonstration of how you can do some of this stuff on your calculator, I'd be happy to do that. Anyway, so we'd be 95% sure that the true proportion in the population who would answer this question, yes, that they believe that there should be laws on industry, is between 0.93 and 0.955, 0.932 and 0.955, so it's a very high percentage. The follow-up question that they ask is kind of silly. It does say, can you conclude that a majority of population would answer yes? And I would say, yeah, we're pretty confident that over 90% of the population is going to answer yes, if you look at these two numbers. So there would be a drastic, very convincing majority of people who would answer yes to this question. Okay, so in StatCrunch, all right, that's what the final screen looks like. Anyway, in StatCrunch, if you go into you could go into a blank screen in StatCrunch and or just open anything. You can just have data in there, but you'll ignore it. Under stat, you'll see something called proportion stats and one sample with summary. So those are the options that you would choose. If we were working directly from the data, in other words, if I had the 1,492 survey results in StatCrunch, then we would say with data. But we don't. We have someone who's told us the counts of how people answered. So that's what they mean by with summary. So if you choose that, then the screen will look like this. And you can see you have two options here for what you're going to do, a hypothesis test or a confidence interval. And so those are exactly the two things that we're talking about right now. So for a confidence interval, all I need to add in here is the number of successes over the total number. So this is the number of yeses to my survey question. And this is the total number of items in my sample. So that's the summary information from the survey that I would add. I make sure I have this confidence interval selected. I tell it that I want a 95% confidence interval. Obviously, that's where if you wanted a 98% or 90% or 99%, you would just change that. And then you hit compute. When you do that, the screen looks like this. You get a summary. It kind of just throws up everything at you. It reminds you of your original numbers. It tells you this sample proportion. So that's p hat. Here's the standard error. So that's the thing that we got by hand by doing this calculation. So it's taking that off the table for us. So it's doing that calculation for us. Notice it's not reporting the margin of error, but we could figure it out because to get the margin of error, well, to get these limits, this is the lower limit of the confidence interval, and this is the upper limit. So this is your confidence interval between these two numbers. And so you can see here 0.932 and 0.955, 0.955. If I round to 3 decimal places, those were my two values that I got by hand. So the only thing it's not showing us is the margin of error, but we know that the margin of error was used to subtract from, subtracting from this gave you this, and adding to this gave you that. So if you really, really wanted the margin of error, you could figure it out from this, because it's just how far each of these limits are from p hat. Anyway, but that takes a couple of steps out of the way, and the nicest part probably is this step, that it takes away this calculation of standard error, where that's a place where you most likely to mess up on your calculator.